Okay, I've put a new assignment together for you all too. Now you're some of you probably aren't going to watch this till Monday, but this is on Friday, so I've already put an assignment. But I'll let you know that I've already got it up there. Anyway, I, I thought I'd just introduce projectile motion, but there's a lot to this chapter, so I thought that we could cover. So I thought I would continue on, and we'll just kind of go through the slideshow here, so you can see it, and then I will add another video recording where we actually um, talk more about projectile motion. Okay. Now, under the influence of gravity alone on Earth, we're going to talk about projectile under the influence of gravity alone. We're going to find out when we get to air pressure and things like that. In fact, I'm going to show you um, at the end of today how if we use the schoolhouse answer that I'm putting up here to calculate how far a baseball is hit compared to how actually far it actually goes in real life due to drag, spin, all that kind of stuff, then you're going to see there's quite a difference. Quite a difference. Okay, but for right now, when we're talking about projectile motion, the only force is the gravitational force, and so the only acceleration once the ball leaves the bat, once the golf ball leaves the club, once the soccer ball leaves the foot, okay, the only acceleration that is being experienced is in the negative 9.8 meters per second squared. Okay, all right. Now, so an airplane is moving horizontally. This is a classic problem. This is a classic problem. We want the two at an altitude of 1,050 meters. It's like about 3,000 feet, and it's going to drop this package. Determine the before the care package hits the ground. Okay, hopefully this care package is well protected because it's going to be going pretty darn fast. One of the things I want you to notice is when it's released, 115 meters per second, notice that x component never ever changes. The x component never ever changes. Okay? Determine the time required to hit the ground. So, the only place that we can figure out the time required to hit the ground, we're going to want to solve two things with this problem. We want to find out where it hit the ground and how long it was in the air. We have to find out how long it was in the air first. Okay? So I'm going to do it and then show you the slide. I'm going to do it with my ladybug and then show you the slides. Okay? So they told us, now, if I can find my pen, here it is. All right, so they told us airplane. At a height 1,050 meters, okay? Drops a package that has an initial velocity in the x direction of 115 meters per second. Two things I want to find. Time in the air and the range. Where's it hit? Okay? And the final velocity. And so the range is where it hits. Okay? Now this is a half a projectile problem because we're just dropping it up at the top. In the next lesson, next video, I'll show you a full projectile motion. All right, so here we go. 115 meters per second, t equals 0. All right, here we go. Sorry about that. Okay, so in the x direction, v naught x is equal to 115 meters per second. V final x is equal to 115 meters per second. Acceleration in the x direction over here is 0. All right, the range, I don't know. But once I find out the time in the air, the range is real easy. V naught x times t. The range becomes really easy because that's at a constant velocity. Boom, I know how far the range is. Okay, so let's write down what we've got in the y direction. V naught y is equal to 0. Right when that package is dropped, The initial velocity in the y direction here is 0. V final y, I don't know. Height, y initial, 1,050 meters. Y final, 0. Acceleration in the y direction, negative 9.8 meters per second squared. Well, right away you're going, hey, I think I can figure out the time. I think I can figure out the time it was in the air because I know with my equations of kinematics, I go, hey, y final is equal to y initial plus v naught y t minus 1/2 gt squared. Sweet. Because I've got 0 equals 1050. Now this is the way I solved it. Some of you might have gone, no. I wanted to find the final velocity using, I could find the final velocity. I could go, hey, final velocity y squared is equal to 0 squared minus 2 times 9.8 times 0 minus 1050. And then I find the final velocity. I can find the time in the air because I know that v final, y, which would be negative, is equal to negative gt. That's another way to go. You can do it that way too. Okay? Just remember. Vy final, look at that, negative. All right? But when you go to solve this guy, it's going to be positive because you're going to be taking square root. So I like my way here. But it doesn't matter. Plus 0 times t minus, 1/2 of g is 4.9 t squared. So add that 4.9 t squared to both sides. I get 1050 meters, 1050 meters. And so t squared is equal to this 1050 over 4.9. See, this is meters and this is meters per second squared, so that cancels. That goes up here. Take the square root. 1050 divided by 4.9 second square root. Oh, wait. Delete. Enter. So that's about 214. Square root of 214 is 14.6 seconds. Okay, so that's the time in the air. All right, so my range is now easy. Range would be 115 meters per second times 14.6 seconds. 115 times 14.6. 1,679 meters. And the final velocity is equal to the square root of v naught x squared plus v final y squared, because these two guys are the same. Oh, I didn't figure out what v final y was. Well, that's easy enough because I know that v final y is equal to 0 minus 9.8 times 14.6 at. V naught y minus at. So the final speed is negative 9.8 times 14.6. And, oh, look at that. Yeah, negative 143 meters per second. All right. And so V final is equal to 115 squared plus negative 143 squared. Take the square root. You know what? I don't think my calculator does that very well. Oh yeah, it did. It did. 183 meters per 183.5 meters per second, and we could find the um, angle would be the inverse tangent of 143 over 115, but we know this is going to be below and plug that in, and then it's below the positive x-axis is your direction. There you go. Now let's check out how they did it. Let's see how they did it, because that's the tricky part. Is there's several ways you can do it. Okay, so here they're putting all their info in. T I don't know, and they said, hey, in the y is where you find the t. Here we got our 14.6. What are the final velocity? V naught. We got to find out what y is. Well, we use this equation like I did, 143 meters per second. That's good. All right. So now we can solve the different kind of projectile motion too. Okay. We'll do the schoolhouse way, and that'll be in the next show.